And welcome back to General Chemistry class. So right now we will be discussing study session 5 with the topic chemical equilibrium and chemical kinetics. Chemical equilibrium and chemical kinetics. What do we understand by the term chemical equilibrium? What do we understand by the term chemical equilibrium? Chemical equilibrium is said to be the condition that occurs when the concentration of reactants and products participating in a chemical reaction exhibits no net change over time. That is to say, when a chemical reaction is taking place at both reactant side and the product side, when the reactants and the products are not undergoing any kind of increase or decrease in their concentration, when there is no increase or decrease in the concentration of the reactants going through chemical process to give us products, when there are no increase or decrease, when there is no change in concentration, that means that that reaction is said to have gotten to a point of chemical equilibrium. Now, under this topic, there is something we call Le Chatelier-Brown principle. This is the name that is given to the principle in which a change in a chemical system prompts an opposition reaction. In chemistry, this principle was discovered independently by Henry Louis Le Chatelier and Carl Ferdinand Braun. And this principle states that is Le Chatelier-Brown principle. This principle states that if the temperature, concentration, volume, or partial pressure of a chemical system at equilibrium changes, then the equilibrium shifts to compensate for the chemical change. That is, if peradventure a factor like temperature or concentration or volume or partial pressure in a chemical reaction changes, so the equilibrium will shift. The equilibrium of the reaction will shift to compensate for the chemical change. Now, under chemical equilibrium, we have what is called the law of chemical equilibrium. The law of chemical equilibrium. Now, if we have a reaction where A is reacting with B from the equation that you can see on this slide, where A is reacting with B to give us C and D. Now, A and B are the reactants. C and D are the products. The equilibrium constant. The formula for equilibrium constant is concentration of the product divided by the concentration of the reactant. Now, if we see this equation now, where we have Kc, Kc is what we call the equilibrium constant, equals to the concentration of the product, which is C and D, raised to power C and D. Now, divided by the concentration of A and B, which is the reactant. Now, the concentration of A, B, C, and D, they are the molar concentration of A, B, C, and D, while the lowercase of A, B, C, and D are what? Are the coefficients in the balanced chemical equation. That means the mole fraction. The coefficients in the balanced chemical equation, that is the mole fraction of the reactants and the products. So in summary, equilibrium constant, the formula for equilibrium constant is what? The concentration of the product divided by the concentration of the reactants. So then we move to what is called chemical kinetics. Chemical kinetics. Chemical kinetics is the study of chemical processes and rates of reactions the study of chemical processes and rates of chemical reaction. When a chemical reaction takes place, reactants are combined to form products. That means that before a chemical reaction can take place, we must have reactants to come together, to combine to form products. Now, how fast or the time that takes the reaction to take place is what we call reaction rates. How fast these reactions take place is what we call reaction rates. Reaction rates are expressed as concentration per unit time. Now we have different types of reaction rates. Reaction rates can be categorized into different orders. We have the zero order reaction, we have the first order reactions, we have the second order reactions, and we also have mixed order reaction. We also have mixed order reaction. Thank you.